Hello everyone, I am Vaishali Girthar from the University of Washington, Tacoma. Today I will be presenting an interactive system to compare, explore, and identify discrepancies across map providers on behalf of myself and my co-author Ayush Bandil. I would also like to give special thanks to Professor Muhammad Ali and the Microsoft Corporation for their continual support and guidance throughout our research. This project is a collaboration between UW Tacoma and Microsoft. As of 2019, the global maps industry is valued at around 6.2 billion US dollars with over 10 global map service providers. Although maps providers strive to maintain high accuracy in maps data, no map provider's data is 100% correct and may have some inaccuracies with respect to the ground truth. This could be due to the dynamic nature of road networks. These minor inaccuracies may lead to unsatisfactory user experience while using map services. In our research, we identified two major causes that could lead to inconsistencies amongst map service providers. One, data inconsistencies in the underlying road network graph and the ground truth. And two, differences in routing algorithms used by each provider. Our work is motivated by the need to identify inaccuracies in road network graphs and improve the maps correction process by aiding cartographers to quickly detect discrepancies among different map service providers. Our research focuses on comparing three major global map service providers: Bing, OpenStreetMap or OSM, and Google. To this extent, we propose a scalable and interactive comparison-based system to enable users to automatically detect discrepancies across maps providers and to evaluate, classify, and categorize the identified discrepancies using automation and visual inspection. The idea behind our approach is to compare the routes generated by the three engines for the same start and end point, then force the reference engine to follow the route proposed by a referent or toEval engine. The forced routes are generated by forcing the toEval engine to pass through selected via points from the reference route. The forced toEval route is then compared to the reference route to identify any divergence and convergence or DICON points. These DICON points, along with the subroutes between them, indicate a discrepancy between the two engines. The discrepancy is then classified as either geo or data discrepancy or a routing discrepancy based on the subroute's distances and geometry. When we do not have enough information to classify a discrepancy as geo or routing, it is classified as misinfo. This image shows the system architecture. The route generator module is responsible for generating a coordinate dataset, which is then used to generate routes for discrepancy analysis. The route analysis module provides an interface that allows the user to visualize the routes, including forced route generation using live data, and to see the route statistics such as route distances and durations. And the discrepancy identification and classification module that automatically identifies discrepancies between the providers and classifies them as geo, routing, or misinfo based on their route distances and geometry. Our system is a web application with four main interfaces. The dashboard interface shows the route statistics, including the number of routes generated, the start and end coordinates, the route distances and durations, and the percentage overlap and average deflection between routes of any two engines. The discrepancy statistics, including the number of discrepancies identified in each region, as well as the discrepancy subroute statistics, which are similar to route statistics, and quick links for system navigation. The data loading and collection interface allows users to define an initial coordinate dataset using points of interest and randomly generated coordinates, and generate routes based on user-defined metrics such as minimum, maximum, and average route lengths and number of routes. The data analysis and visualization interface allows users to view all the discrepancies identified by region, view the discrepancies on the roadmap of each provider, rate a discrepancy based on importance after visual inspection, filter discrepancies based on discrepancy type and user rating, and export discrepancies data as a spreadsheet or GeoJSON containing the DICON coordinates, discrepancy type and rating, and subroute distances and durations. The discrepancy evaluation interface allows users to visually inspect each discrepancy using satellite view and street view, and manipulate the DICON coordinates using drag and drop to reevaluate the subroutes using live data. To conclude, our research uses a comparison-based approach to identify discrepancies across different map providers. To test our system, we generated over 6,500 routes in New Zealand and identified 1,900 discrepancies with up to 80% true discrepancies. This indicates that our research is effective in quickly identifying discrepancies across maps providers. We are continuously improving our research and are currently working on adding machine learning techniques for automatic discrepancy classification based on the cause of the discrepancy. I thank you for your time and I'm happy to answer any questions you may have.